So for the example, if you notice there's a 5 outside, that means that all of this piece is going to be raised to the power of 5. My suggestion is to first condense this part to be one log function, and then you raise everything to the power of 5, which is your exponent. So since we have an addition here, that means these two pieces are being multiplied. But don't forget, because I did it when I was doing mine first, there's also another 0.5 right there. We know that 0.5 is the same thing as a half, which in an exponent, a half means it's a square root. So now we have 5 log of x plus 6, and the square root of y plus 4. And the reason that it's a square root is because of this 0.5. Okay. And then we have minus, and we're going to put this to here because that's our exponent. So now we have minus log, and I forgot the 0.5, of 0.5 z plus 3 squared. Then we're going to have log of 0.5 x plus 6 to the 5th power, and y plus 4 to the 5th power. You could also have this 5 right here. You could put a parenthesis over the whole square root into the 5th power. It's basically the same thing. Minus log of 0.5 z plus 3. You could technically already have done the answer on that step, but I'm trying to show you every single step. So the next piece would be log of 0.5 x plus 6 to the 5th power, square root of y plus 4 to the 5th, all of that divided by your bottom part, which is going to be z plus 3 squared. That's your answer for that first part. So for part B, we have, again, a -3, and that -3 is going to be an exponent for our inside portion of our log. So we will have, let's simplify the inside first. So we're going to have the 3 log, and since they're being added, that means they're being multiplied. So we're going to have y minus 5, and then we have this 2 right here, so that means that's going to be an exponent for that x right there. So we had x squared plus log of z minus 8. Then we're going to raise everything to the power of 3. That means this right here and that. So now we're going to have log of y minus 5 to the 3rd power. And now we know that 3 times the 2 is 6. So it should be 6, not 5, sorry. And we're going to have times z minus 8. So again, this should be a 6, not a 5. And that should be your answer. So this is kind of like what we did earlier in the week, but we're going to write it in simplified exponential form. So we want the 81 and the 27 to be the same base. So if you're good at multiplication, this should be really easy. 81 and 27s are multiples of 3. So we know that 81 is 3 to the 4th power times that original x that was in our exponent. And we know that 3 to the 3rd power is 27. Now that we have the same base, you drop your bases, and you're going to have 4x equals to 3. Solve, and you're going to have that x is equal to 3/4 is our value, or I have x. For B, it's kind of the same thing. You want to make it into powers of 6. So we know that 36 is 6 squared. So we're going to have 6 squared times that 5x plus 2. And we know that this is 1 over 6 to the 1 power. We're going to move that 6 to the numerator. So we're going to have 6 to the negative 1 times 11 minus x. And now we're going to use our properties of exponents. And we are going to multiply those things out. So we're going to have 6 is 10x plus 2. And negative 11 plus x. And since we have the same base, we could drop the bases. And now we're going to have... So we're going to drop that, and we're going to have, that should be a 4. So we should have 10x plus 4 is equal to negative 11 plus x. We're going to subtract the x from both sides, subtract the 4 from both sides. These 4 reduce or go away, cancel, those cancel. So we're going to have 9x is equal to negative 15. Divide both sides by 9. And since 15 and 9 are multiples of 3, we could divide both sides and reduce. So we should get negative 5/3 as our value of x. Since there's no way we could write 27 and 5 to be the same base or to write them as exponential form, that means we're going to be using our properties of logs. So what we're going to be doing is, since our variable is this one, we want to get rid of that 27. So the only way to get rid of that 27 is to raise it to the power of log. So take the log of 27 on both sides. So we can get rid of that 27. So we're going to have a log of 27, 27x minus 4 is equal to log 27 of 5. These go away, and I'm going to have x minus 4 is equal to log 27 of 5. We're going to add the 4 to both sides. And we're going to have x is equal to log 27 of 5 plus 4. And if you put that in your calculator, and there is a way to change the log. For sure, I know there's a way to change the log base on the TI calculators. I don't know if you could do that on the more simple calculators, but this is your answer. But your approximation would be 4.49. That would be your answer. So for this example, the first thing we would need to do is, let me rewrite it first. So we have 27x minus 4 plus 6 is equal to 5. We're going to subtract 6 to both sides. And we have 27x minus 4 is equal to negative 1. Since we have our exponential function equal in a negative number, that means this number is going to make it no solution. And the reason that is, we're not going to have a solution is there's no real value of x that will make the equation a true statement, because any power of a positive number is positive. So think of it this way. If you're graphing 27x minus 4, that's something that's going to be looking like this. Negative 1 is down here. They're never going to cross. So there is no way that there could be an actual solution, because they will not cross, because your exponential function is always going to be positive. So no solution, because any power of a positive number is positive. So for this problem, now we're going to do E's exponential. So we're going to solve. These are just equations, with the exception they have a E on it. 21 minus 6 is 15. To get rid of the E's, we're going to take the ln of both sides, and the E cancels. So we're going to have x is equal to ln of 15. And this is the exact answer. My approximation, if we put it in the calculator, should be approximately 2.71. That would be my other answer. So this right here is my exact answer. And this is an approximation. So if I give you something on a test, make sure you read the instructions, because I might ask you for the exact answer, or I might ask you for an approximation. For part B, same thing. We add the 3 to both sides. we're going to have 3e to the x is equal to 18. Divide both sides by 3. We're going to get e to the x is equal to 6. Take the ln of both sides. And we're going to have x is equal to ln of 6. This is my exact answer. And my approximation, once I put it in my calculator, should be about 1.79. So for this problem, we're going to compress it first on the left side. So we're going to have log of 4 is 2x is equal to 2. We are going to write it as an exponential function. So we're going to have 4 squared is equal to 2x using our properties of logs and exponents. So remember, this one went here and this one goes this way. Now we are going to simplify it. So we know 4 squared is 16 equals to 2x. Divide both sides by 2, and we get that x is equal to 8. Easy peasy. Next one, same thing. We're going to condense or compress that ln. So we're going to have ln of 5x is equal to 25. We need to get rid of the ln, so we're going to raise it to the power of e, both sides. So we're going to have 5x is equal to e to the 25th. We are going to divide both sides by 5, and we're going to have x is equal to e to the 25th over 5. That is my exact answer, and my approximation would be 1.44 times 10 to the 10th power. And that's just the calculator gave it to me. Since our x is -8, which is our argument in this case, because this right here, when we're doing logs, these are basically your arguments, are negative, you're going to have a -8 there and -8, which becomes a -4. It can't be negative. We talked about it earlier. It can happen. So this means this is undefined because of the -8 argument. So make sure that just because you get an answer, it actually works out. So if you look at it and it does not make sense, log 2 of -8, you're not going to have a negative number. You can't have a negative argument. So for part B, we're going to do the same thing. Hopefully we don't get a negative argument. Let's see what happens. So we know that the subtraction sign means division. So we're going to have log of 4, x over x minus 2 is equal to 2. We're going to write this as exponential form. So we're going to have 4 squared is equal to x over x minus 2. We're going to have 16 is equal to x over x minus 2. We cross multiply, and we're going to get 16x minus 32 is equal to x, because I just cross multiplied. Subtract the 16 to both sides. We're going to have -32 is equal to -15x. Divide both sides by a -15, and we get that x is going to be 32 over 15. So since it's positive, that's my answer. We don't have a negative argument. So for this one, we're going to simplify it, and we don't know what our value of x is. Just because there's a negative there doesn't mean it's not going to eventually turn positive. We don't know what it is yet. We need to figure it out. So we're going to have log of 4. Since it's addition, we know we're going to be multiplying. So we're going to have -x, x plus 10 is equal to 2. So we're going to have log of 4, -x squared minus 10x is equal to 2. I need to get rid of the log, so I'm going to raise it to the power of 4 so I can get rid of it. So that goes away. Now I have negative x squared minus 10x is equal to 16. I'm going to move everything to one side. So I'm going to have 0 is equal to x squared plus 10x plus 16. I'm going to factor this out. And I'm going to get that x is going to be plus 8 plus 2. And I get that x is equal to negative 8 and x is equal to negative 2. But if you notice, when I substitute this negative 8 or the negative 2 in here, it makes it a positive argument. And if I do negative 8 plus 10, it's still going to be a positive argument. And negative 2 plus 10 is still a positive argument. So these are our solutions. So make sure that you're looking back and making sure it makes sense. So for our part B, same thing. We're going to have log of 6 is 3x times x minus 3 equals 3. We're going to simplify that. And we're going to have 3x squared minus 9x is equal to 3. And apparently, I don't know how to write things because this should have been a 1. And that means this should have been a 3. Sorry about that. I'm going to raise it to the power of 6 because I want to get rid of the log. So now I'm going to have 3x squared minus 3x. And 6 to the third power is 216. I'm going to make that all equal to 0 so I can solve it. So we have 3x squared minus 3x minus 216. I believe they're all divisible by 3, so I'm going to factor out a 3, so it makes it easier for me to factor. So that should be negative x squared minus x minus 72 is equal to 0. If I factor that out now, I should get x minus 9, x plus 8. And I'm going to get that x is equal to positive 9 or x is equal to negative 8. So now I'm going to check if it makes sense. So if I put a 9 here, I'm going to get a positive argument. That works. If I put 9 in here, I'm going to get a positive argument. So 9 works, so that's an answer. So let's put the little box on that one. If I put 8 here, I'm going to get a negative argument, so that's not going to work. And I'm going to have a negative argument here, so that one doesn't work. So this is basically an extraneous solution or a solution that doesn't work. So our only answer for B is x equals 9. Okay, I believe this might be our last example that we're going to do. This is a lot like the ones we did earlier. I guess this is just for extra practice. So add 6 to both sides. We're going to have 5e to the x is equal to 8. Divide both sides by 5. And we're going to have e to the x is equal to 8/5. We want to get rid of the e because we want x by itself. So take the ln of both sides. And we're going to get that x is equal to ln of 8/5. That's my exact answer. My approximation would be 0.47. That would be my approximation. So both are valid answers. Just make sure it depends on what I'm asking you on a test. If I don't say, then I'll take either or. For B, same thing. We're just using our algebra skills. We're going to add 3 to both sides. We're going to have 1/3 5 to the x power is equal to 18. Multiply both sides by 3 to get rid of that fraction, so that goes away. Now we have 5x is equal to 54. Since I don't have any e's or logs, I'm going to write this as a log, so because it's an exponential form. So I'm going to have that x is equal to log of 5, because now that becomes my base, of 54. If I put that in my calculator, I'm going to have 2.48 as my approximation.